Friends, today we are going to discuss the parallel and series operation of centrifugal pumps. So the first picture you see, this is the series operation of a pump. The suction, discharge of the first pump. Suction is this, discharge is this. Then second pump taking suction from the discharge of the first pump and discharges to the system. This is called series operation. This is the parallel operation. It is taking from the same manifold and discharge same. If it is same pump, same discharge pressure, it is going to the same manifold and going out other manifold and going to the other system. So this is the series operation of the pump. This is the parallel operation of the two pumps. Now, when the two pumps are running, two identical pumps are running in series, what will be your performance curve when both are running? So this is single performance curve. This is performance curve of single pump. This is both are identical pumps. So when the second pump will be in series, so there also the pressure development will be the same. Here the pressure is this much. So this plus again the pressure of the second pump also the same. So this will be your new operating point. This will be your new operating point for the same flow. Suppose this flow is here. So this is your head. So this is your head. So again you add the same head because this distance of the first pump will go to the suction of the second pump, and so pressure development will be the same. So this will be the second point. So this will be the common performance curve when two pumps are running in series. But your operating point will not be the here, or not will be here, not will here. Your operating point system resistance curve will like this. When pressure increase, flow will certainly be decreased. Pressure drop will be there. As the high pressure is there, there will be pressure drop. First pressure pump pressure drop will be different. Second pressure pump pressure drop will be different because the pressure is high. Second pump pressure is high. So your new operating point will be pressure, discharge pressure, common discharge pressure will be here, and now your capacity will also here, not here. Capacity will also increase. Discharge pressure will when two pumps are running in parallel, identical pump running in parallel, then instead of here, it will be operating here. So why we are using the two pump running in parallel? Because two pump running in series, because suppose your pump is handling a corrosive or volatile material, so there is a chance that it can evaporate. So evaporate if you use a single pump. So instead of that, what we are going to do, we are increasing the pressure for the suction, increasing the pressure of the second pump, so that cavitation first from here to here and then from here to the discharge pressure. So this will help to avoid the cavitation of the second pump. Now two pump running in parallel. Before running in parallel is this pump, common suction, and then this is discharge, again going to the system. So how will calculate, how will draw the common performance curve? Because this is your pump, both the pumps are having the identical pump, means your shut off pressure done head versus Q are same. So if you know the capacity, if suppose you want to calculate, you draw the common performance curve, you suppose you flow 1 point, the flow of other pump will also from here to here. So from it is the first pump flow, second pump flow we have to add, means 1 to 2 is equal to second for second pump also it is from here to here, that is 1 to 2. So you have to plot it like second point you are going to get here. So your common for this pressure when two pumps are running, your PA head versus Q curve will be like this. But I have told you, when the flow is increased, there will be a pressure drop. Flow is increased and there will be different pressure drop. Different pressure drop of the second pump. So your different pressure will be second pump. So your instead of running here, it will be running here, and your flow will come down, but discharge pressure will be slightly high because due to the change in pressure because the quantity, sorry, here particular case, the quantity will increase, velocity will increase, so your pressure drop will increase. So here you see the discharge pressure will going to increase, discharge pressure is going to increase, at the same time flow will come down. Certainly flow will come down. Certainly flow will come down. But pressure drop will remain same. But as the both pump are same, so pressure drop will be the same, but the flow has increased, velocity has increased, so pressure drop will increase. So your new pressure drop will increase. So discharge pressure will be higher than the common performance curve, and your palm will run. This palm will run this point. Of the suppose both the palm shut off head is same, but different performance curve, for this type of parallel operation, what will happen, what will be your how you will draw the performance curve of the common pumps, performance curve of the two pumps. Now if you see, suppose for this flow, this flow, this is cutting the performance, this flow, this head, this is cutting the performance curve on this, and for this head, cutting the performance curve at this. So you have to add this plus this, that will give you the point of your second common performance curve. Similarly, for this flow, this is cutting for this head, this is cutting the performance curve of first pump here and cutting the performance curve second pump here. So what will be your new point? Now this point, for new flow will be this point plus performance flow of first point from here to here. You have to add, that will give you the performance second point of your common performance curve. And normally this will be your system. So system resistance curve normally we prefer, because it is a minimum flow requirement. Then system resistance curve will mostly operating region will be these two, from here to here. Similarly, suppose two pumps are running, the performance curve are not same, and your shut-off pressure is also not same. This is the performance curve of the first pump. This is the performance curve of the second pump. Shut-off head is different. Performance curve stiffness is also different. How will plot the performance curve of the common pumps? Now, if you see for the pressure here, this pump cannot generate any pressure because this pressure required pressure is high. So for up to from here to here, the performance curve of the second pump, the performance curve, the common performance curve will follow the performance curve of the second pump. And from below this, suppose your pressure is here, so it will cut the first performance part here and cut the second performance curve here. So you will get the performance point, common performance point here, because you have to add this plus this, that will give you the second performance curve point here. So your performance curve of these two pump running with differential head, total shut off two different shut off head and two different performance curve, then it will be like this, from here to here and from here to here. This will be your common performance curve. Up to here only pump 2 will come, and up to there, after that the second performance, second pump will come in picture, and that will be your allowable working range of the pump, because this is the shut off head of the second pump. So this you have to take it granted. From beyond this it will not working. So from here to here it will be your allowable working range. Now, stable pump and unstable pump. For stable pump, if you have seen the performance head versus Q curve, head is normally going downward, power is going upwards. But unstable pump, you see, for the same head, you are getting two different flow. You see the shut off head, again you are getting one is 0 and another one is here. Similarly, for this head, you are getting operating point here. You can get operating point here also. So this is unstable. But for same head, you are getting two different operating point. You see, this is the shut off head. You are getting to either maximum or minimum. So this is your unstable performance curve, because from this region to this region this performance is unstable, because suppose it is running in this pressure, so it can run here also, it can run here also. So your there will be fluctuation. So beyond that, beyond this point, your performance, you can operate this pump, there will be no problem. But up to this region, it will not work. At this point, that's why the point is called intersection will be only for this. You see, intersection only for one head. For one head, it will cut the performance curve only in single point. But here, you see, in between these two, if you for one head, it will cut the performance curve at 2 points. So that's why it is called unstable. This is called unstable. Because at common head, suppose this is head, it will cut this performance curve 2 points, but here it will cut the performance curve in one point. That's why it is called stable. And when the this point, it is called unstable. From here to here, flow is not stable. Two flow can take place. Beyond this, the pump can be run. Right hand side of this one. This is 1, this is 2. Here now. Now we are going to discuss the two common sort of head, but two unstable pumps. This is the performance curve of first unstable pump. This is the performance curve of second unstable pump. So if you see, this is your unstable region of the first pump. This is the unstable region of the second pump. This is the unstable region of the second pump. So up to this, there will be flow will be unstable. Flow will be unstable, and the flow, how much it will be? Now this common performance curve will be, this is the first flow, and this is the flow of the second pump. You have to add this one, so you will get the point here. You will get the point here. Now for suppose for this head, it is cutting the, beyond this it is stable. Beyond this it is stable. So this head, both the pumps are stable. So how will get the common point? Now this distance plus this distance from here to here is equal to here to here. So you are getting this point. So beyond this one, this point is your operating point of the two pumps when common sort of pressure but different unstable performance curve. Their operating can also be done, but their operating range will be very slow. Up to here there will be no unstable flow. Unstable flow. Now you see different cutoff head and unstable curve. That also can be done. Suppose this is your first pump having pressure cutoff head. This cutoff head is here. This is your second pump. This unstable. This one is unstable portion. This is your second performance curve of unstable curve. This is unstable portion is from here to here, and sort of head is also different. Sort of head is also different. So up to this, this is the transition point. You see, if you beyond this flow, beyond this flow, though this pump is working, stable flow, but for this pump, it is unstable. This pump, it is unstable. For this pressure, suppose for this pressure, this pump is working, stable condition, but this pump is not stable because here it is unstable condition. So this is the point. It is called transition flow, and beyond this, again you are going the operating point. You are again going the operating point. And not only that, here you are above this point, above this flow. The flow is unstable, and at the same time, this one pump will be running. This pump cannot discharge any pressure because pressure is here. So this will be your only, from here to here. This will be your only stable operating range for this type of parallel operation of two unstable pump and two different sort of head. Next is when one plunger pump and one centrifugal pump is running. You know, the plunger pump for same flow same flow, flow will remain steady for different pressure. Flow is remain steady, remain constant for different pressure, and this is the performance curve of a centrifugal pump. When these two pumps are combined, what will happen? You see, this is the this flow on this for this head. You see, up to this head, this will this head, this point plus this point, you will get the this point, and you have to always add. Add in the which is almost constant. Means piston pump flow rate is almost constant. When you see the QC, it's almost constant. So how will get this point? Now K0 is a flow. K0 is the head. K0 is the head of this one. K0Q plus H1F. H1F is the head of this one. So if you add these two, you will get the value of this one. This point is your stable operating point. Here you can operate your pump. If a plunger or piston pump and the centrifugal pump operated in parallel, the flow of the piston pump Q is constant, which is almost constant over the head or different head. The flow is more or less constant. So for this head, this will be your flow plus this is your the centrifugal pump flow. So you will get the point here, which is almost constant over the head and is added to the centrifugal pump flow rate. So it is the centrifugal flow plus this flow. If we add like this, suppose your point is here. Head is here. So how much you will this is your performance curve of the centrifugal pump plus this is more or less constant. If you add this one, then you will get another 1 point here, So that is also that operation. One plunger pump, one centrifugal pump is also possible. So friends, I have discussed the series and parallel operation of centrifugal pumps and plunger pump also. I think if you go through these slides, your all concept will be clear. If you still have any more question, you can ask me in my mobile number or in my mail ID. I'll certainly reply you. But in the interview board, they may ask you to draw the common performance curve when both the centrifugal pump are running in series as well as in parallel of same sort of heat, different sort of heat, stable curve, unstable curve, and plunger pump with a centrifugal pump. So this question may arise, and if you go through these slides in attention, then your concept will be clear. No problem.